Lecture 16. Accidental breakthroughs in the shadowy corners of a laboratory left unattended for a summer holiday, invisible spores drifted through the air. They settled on an abandoned petri dish, where they would silently orchestrate one of medicine's most profound revelations. When Alexander Fleming returned to his messy lab in September 1928, he beheld something perplexing: a mysterious zone of inhibition surrounding a mold contamination in his bacterial culture. That moment of bewilderment would eventually save millions of lives through the discovery of penicillin. Welcome to Unusual Science, where today we venture into the enigmatic realm of accidental breakthroughs. I'm your guide into this labyrinth of unintended discovery, where humanity's greatest advances often emerged not from methodical planning, but from the mysterious dance of chance and observation. The history of science is haunted by these moments, when brilliant minds stumbled upon world-changing discoveries while searching for something else entirely. As we'll see, these serendipitous encounters have transformed medicine, materials, physics, and our very understanding of existence itself. What exactly constitutes an accidental breakthrough? It's that baffling moment when a scientist, puzzled by an unexpected observation, chooses to investigate rather than discard. Louis Pasteur, whose own career benefited from several such moments, famously declared, "Chance favors the prepared mind." This cryptic phrase illuminates a paradox at the heart of scientific accidents. The discovery may be unplanned, but recognizing its significance requires a mind trained to perceive meaning in the unexpected. In the labyrinth of scientific progress, wrong turns sometimes lead to the most valuable chambers. The scientist who remains enchanted by curiosity, rather than frustrated by deviation, often unlocks doors that weren't even known to exist. Let us delve deeper into Fleming's perplexing encounter with penicillin. The Scottish bacteriologist had been researching Staphylococci bacteria when he observed something inexplicable: a mold contamination creating a bacteria-free zone on his culture plate. Where others might have discarded this contaminated experiment, Fleming's prepared mind recognized an opportunity. He isolated the mold, identified it as Penicillium notatum, and discovered it secreted a substance that could destroy numerous disease-causing bacteria. Yet, the path from observation to medicine remained shrouded in mystery for another decade, until Howard Florey and Ernst Chain developed penicillin into a viable treatment during World War II. This accidental discovery has since saved countless millions of lives. The veiled secrets of the human body were dramatically illuminated in 1895 when physicist Wilhelm Röntgen was experimenting with cathode rays. He noticed something utterly bewildering. A fluorescent screen across his laboratory mysteriously glowed when the cathode ray tube was activated, despite being shielded. These invisible rays that could pass through objects became known as X-rays. In an eerie first demonstration, Röntgen captured an image of his wife's hand, complete with wedding ring and skeletal structure. Upon seeing her own bones, she exclaimed, "I have seen my death." This macabre moment heralded a revolution in medical diagnosis, allowing physicians to peer into the body's hidden chambers without surgical invasion. Röntgen's chance observation transformed medicine forever. The realm of sweetness holds its own tale of scientific serendipity. In 1879, Konstantin Fahlberg was investigating coal tar derivatives at Johns Hopkins University when he forgot to wash his hands before dinner. Biting into his bread, he was startled by an inexplicably sweet taste. Tracing this mysterious sweetness back to his laboratory, he identified saccharin, a compound 300 times sweeter than sugar with no caloric value. Similarly baffling was the accidental discovery of aspartame by James Schlatter in 1965. When he licked his finger to turn a page and encountered unexpected sweetness from a compound he had synthesized for ulcer drug research. These chance encounters with sweetness would eventually transform our food landscape and offer alternatives for diabetics worldwide. Perhaps the most mystifying and commercially triumphant accident of modern pharmacology occurred in the 1990s, when Pfizer scientists were testing compound UK 92480 for treating hypertension and angina. The clinical trials revealed an unexpected side effect that seemed at first like a curious footnote. Male participants reported a peculiar phenomenon, spontaneous erections. Recognizing the potential, researchers pivoted their investigation, and Viagra was born. This enchanting tale of scientific redirection transformed a cardiovascular medication failure into a blockbuster treatment for erectile dysfunction that has generated billions in revenue. The blue pill stands as testament to how carefully observing unexpected outcomes can open entirely unforeseen domains of treatment. The world of materials science is particularly fertile ground for accidental discovery, perhaps because new substances often reveal their properties in ways that defy prediction. In 1942, Dr. Harry Coover was attempting to create clear plastic precision gun sights for Allied soldiers when he synthesized cyanoacrylate. Initially, he dismissed it as a failure because it was too sticky and adhered to everything it touched. Years later, while working at Eastman Kodak, he rediscovered the compound and recognized its potential as an adhesive. The substance that had once vexed him as an annoyance was reborn as superglue, a household staple and emergency medical adhesive that would later be used to close wounds on the battlefields of Vietnam. In the mysterious realm of polymers, Roy Plunkett was investigating refrigerant gases for DuPont in 1938. Upon opening a stored cylinder of tetrafluoroethylene, he was baffled to find no gas emerged, yet the cylinder's weight remained unchanged. Slicing it open, he discovered a slippery white powder coating the interior. This peculiar substance, polytetrafluoroethylene or Teflon, proved to be one of the most chemically inert materials ever discovered, with a bewilderingly low coefficient of friction. Similarly, Charles Goodyear's 1839 accidental dropping of rubber, mixed with sulfur onto a hot stove, led to vulcanization, transforming temperamental natural rubber into a durable, weather-resistant material that would eventually encircle the wheels of vehicles worldwide. The enigmatic Post-it note was born from a failed attempt at creating a super-strong adhesive. In 1968, Spencer Silver at 3M developed an adhesive that formed tiny spheres with a weak but persistent stickiness. For years, this perplexing failure lingered without application until his colleague Arthur Fry, frustrated by bookmarks falling from his hymnal during choir practice, recalled Silver's peculiar adhesive. The temporary, repositionable bookmark became the Post-it note, transforming office communication and generating billions in revenue. This enchanting tale illustrates how recognizing the virtue in perceived failure can transmute disappointment into innovation. The proper application of Silver's failed adhesive simply hadn't yet revealed itself, its true purpose hidden in plain sight for years. The very echoes of creation were accidentally detected in 1964 when astronomers Arno Penzias and Robert Wilson were testing a sensitive microwave receiver. They were plagued by a mysterious noise, a constant background hiss that persisted despite all attempts to eliminate it. This baffling interference occurred regardless of where they pointed their antenna in the sky. After ruling out equipment problems and even cleaning pigeon droppings from the receptor, they realized they had stumbled upon something profound: the cosmic microwave background radiation, the afterglow of the Big Bang itself. This accidental discovery provided compelling evidence for the Big Bang theory and earned the bewildered astronomers a Nobel Prize. Their frustrating noise was, in fact, the universe's oldest light. In 1896, Henry Becquerel was investigating whether naturally fluorescent minerals might produce X-rays when exposed to sunlight. When cloudy weather interrupted his experiments, he stored his uranium salt crystals in a drawer with photographic plates wrapped in black paper. To his astonishment, the plates were exposed despite the absence of sunlight. This perplexing phenomenon revealed that uranium naturally emitted penetrating radiation, a discovery that would lead to the identification of radioactivity. Becquerel's cloudy day accident opened the door to nuclear physics and eventually to Marie and Pierre Curie's isolation of radium and polonium. Another celestial accident occurred in 1800 when William Herschel placed thermometers beyond the visible spectrum while measuring solar heat, unexpectedly discovering infrared radiation in what appeared to be empty space. These tales of accidental discovery reveal an enchanting paradox. How can science, with its emphasis on controlled experiments and methodical research, harness the power of the unplanned? The answer lies in what physicist Freeman Dyson called receptivity to the fruitful accident. Modern scientific institutions attempt to create spaces where controlled experimentation coexists with openness to unexpected outcomes. Companies like 3M and Google have formalized this approach by allocating specific time for unstructured exploration. Yet there remains something mysteriously unquantifiable about the moment when a prepared mind recognizes significance in an anomaly. Can serendipity be manufactured, or must we simply create conditions where it might flourish? Today's hyper-specialized scientific landscape presents both challenges and opportunities for accidental discovery. Big data approaches and artificial intelligence may identify patterns that human observers miss, potentially uncovering connections that would otherwise remain hidden. Yet the increased pressure to produce specific, fundable outcomes may discourage the pursuit of unexpected observations. The scientist who veers from their declared research path to chase a puzzling anomaly may risk their career. This tension between directed research and openness to the unexpected continues to shape how science evolves. Perhaps the most valuable scientific skill remains the ability to recognize when an anomaly deserves attention rather than dismissal. As we reflect on these extraordinary tales of scientific serendipity, a profound question emerges. In an age of algorithmic prediction and targeted research, are we creating environments that still welcome the truly unexpected? The history of accidental discovery reminds us that some of humanity's greatest breakthroughs arrived not when we were looking directly at them, but when they appeared in our peripheral vision. It suggests that alongside our ever more precise scientific methods, we must preserve space for wandering, for mistakes, and for the courage to investigate what appears, at first glance, to be merely an error or an annoyance. The future of science may depend as much on our ability to recognize valuable accidents as on our capacity to design perfect experiments. The mysterious dance between accident and discovery reminds us that science is not merely a mechanical process, but a deeply human endeavor. Each accidental breakthrough represents a moment when curiosity triumphed over frustration, when openness to possibility overcame attachment to expected outcomes. From Fleming's moldy petri dish to Penzias and Wilson's cosmic static, these moments changed our world precisely because someone chose to investigate rather than ignore the unexpected. As Louis Pasteur's enigmatic words remind us, chance favors the prepared mind. Perhaps the greatest scientific preparation is not just knowledge of what is known, but a persistent enchantment with what remains to be discovered, especially when it appears in forms we never anticipated. In our next lecture, we'll explore another fascinating dimension of scientific discovery: the controversial breakthroughs that challenged established paradigms and faced fierce resistance before eventual acceptance. Until then, I encourage you to remain receptive to the unexpected in your own explorations. After all, as these captivating stories have shown us, the most profound discoveries often lurk where we least expect them, waiting for a prepared mind to recognize their significance. Thank you for journeying with me through the mysterious landscape of accidental discovery, where chance and insight converge to expand the boundaries of human knowledge. This is Unusual Science, where we explore the strange, the unexpected, and the profoundly transformative aspects of our quest to understand the universe.